Okay, I would like to talk about the chain rule today. Now, before we do the chain rule, which I'll talk about, I want to review some basic differentiation rules. If our variable is x, if you have x to some power, the power goes down and the old power becomes the coefficient. So for x cubed, the 3 would go to the front, the power of x would go down to x squared. For x to the fourth, 4 went to the front, and we went down to power of x cubed. Okay? Something times x would just be or a number times x would just be the number. So 5x would become 5. Derivative of the constant is 0. Natural log is 1 over x. E to the x is e to the x. So the derivative of this would be f prime of x equals. Okay? The 5 would go to the front, and I will go down a power to x to the fourth. Plus 10. The 3 would go to the front, and I go down a power to x squared. The derivative of minus 7x is just minus 7. The derivative of the constant 4 is 0. Minus 102. The derivative of the natural log of x is 1 over x. And the derivative of 103 e to the x would just be itself. Okay, to simplify this, f prime of x would therefore equal 5x to the fourth plus 30x squared minus 7x minus 102 times 1 over x would be 102 over x plus 103 e to the x. All right. The chain rule. I'll go ahead and put an example on the board from a paper, a set of notes I have in front of me. F of x equals the natural log of x to the sixth minus 8x plus 7. Okay. The chain rule. If f of x has an expression within it, let u equal that expression. Rewrite f of x as f of u. d dx of f of u, the derivative with respect to x of f to the u, would be, you'd apply the differentiation rule to u, and then you would take the derivative of whatever u prime is. You'll need them both. And then you would back substitute and simplify. U can typically be found in parentheses, under radicals, in denominators, or in exponents. Okay, so I will start with f of x equals the natural log of x to the sixth minus 8x plus 7. Okay, well, this will take the role of u. Okay, u prime, which you'll need, is the derivative of this. So that'd be 6x to the fifth minus 8 plus 0. Okay, so that'll be u prime, the derivative of this. Okay, f of u would be natural log of u. Here's the rule for the natural log, 1 over. Natural log of x would be 1 over x. So d dx of f of u would equal f prime of u times 6x to the fifth. Sorry, no, I'm going to go back. F prime of u times u prime. Well, the derivative of that would be 1 over u times 6x to the fifth minus 8. I will now back substitute. 1 over u is 1 over x to the sixth minus 8x plus 7 times 6x to the fifth minus 8. I'm going to take this times 1 and put it over that. So f prime of x, which is that, is going to be 6x to the fifth minus 8 at times 1 over x to the 6th minus 8x plus 7. Okay? All right. Let me turn this around, turn this a little bit and see if I might have room for another example. You zoom out a little. All right. I'm going to try not to step over a chord here. Example 2. No, I think I'm just going to take the whole thing down. All right, so the chain rule. To review that, I'm going to do this problem again. I propose to do the whole problem again. All right. This will take the role of u. So u prime would be 6x to the 5th minus 8 plus nothing, 0. Okay? F of u would therefore be the natural log of u. Okay? So dx of f of u would be f prime of u times u prime. Okay? The derivative of the natural log is 1 over the variable. So 1 over u, and u prime is 6x to the 5th minus 8 in parentheses. Okay, I will back substitute. F prime of x is 1 over this stuff, x to the 6th minus 8x plus 7 times 6x to the 5th minus 8. Okay, so f prime of x is therefore this times this over, this times 1 over the denominator. So 6x to the 5th minus 8 over x to the 6th minus 8x plus 7. All right. Next step, example 2. See if I can get this to fit. F of x equals 5x, in parentheses, 5x to the 19th plus x squared minus 47x to the 25th power. This will take the role of u, so u prime would equal, move it over a little bit, u prime would equal 5 times 19x to the 18th plus 2x to the first, or just 2x, minus 47. So I forgot to put this in parentheses. So u prime would be 95 x to the 18th plus 2x minus 47. Okay. So f of u equals u to the 25th power. Well, folks, the power rule is this. So f prime of u would be 25 u to the 24th. Oops, I'm going to go back again, okay? So the power rule is here. You move the exponent to the front, you go down a power. So dx of f of u would be f prime of u. So you're going to have f prime of u times u prime, which would be 25 u to 24th under the power rule over there, times 95 x to the 18th plus 2x minus 47. Okay? So I'm going to write this fairly small. F prime of x will have to equal 25. I'll go ahead and put this and I'll put this over here. 95x to the 18th plus 2x minus 47. And then the u to the 24th will be replaced by 5x to the 19th plus x squared minus 47x to the 24th power. I hope that fits on the screen. It does. Okay. So that's the idea. Okay? I will do more examples. But as you can see, you are just simply replacing the function with u being an expression. You follow the differentiation rule for the u, but you also take it times the derivative of whatever your u is. It was the same for both of them. Okay? I replaced this thing in parentheses with a u. I applied the differentiation rule to u, but I also multiplied it times the derivative of what was in parentheses. And I cleaned up the mess. Okay? This problem is doable a different way, and I will revisit it when I do it a different way. All right. Example 3. F of x equals 1 over the square root of 46x minus 7. Okay. Here goes. We will let u equal 46x minus 7. It's under a radical, and it's in a denominator. It's a double whammy. Okay? Now, if u equals the radicand in the denominator, then u prime, the derivative, is just 46 minus 0, so just 46. Okay? So, f of x was originally 1 over 46x minus 7 to the 1/2. That's what the square root function means, which is equivalent to 46 minus 7, 46x minus 7 to the negative 1/2 power. Okay? That's using the rules of exponents. So what that means is f of u could be written as u to the negative 1/2 power. So, dx of f of u would be equivalent to f prime of u times u prime. So, that's going to be negative 1/2 u to the negative 1/2 minus first times 46 from u prime. So that will be negative 1/2 u to negative 3/2 times 46, which gives me negative 1/2 times 46x minus 7 to the negative 3/2 times 46. Okay, now 46 divided by 2 leaves me 23. So f prime of x is equivalent to negative 23, negative times the 23, and then you will have 46x minus 7 to the negative 3/2. All right, I'm going to pause it at this point, and we'll do another example. All right, here is another example. Okay? What I'm thinking of is letting u be the exponent and using this rule. E to the x is its own derivative. Okay? But we're going to be having to use u. Okay? So u, will equal x to the 9th plus 28, and that requires that u prime be 9x to the 8th. Okay? That's the derivative. So that'd be 9x to the 8th plus 0, leaving 9x to the 8th. Okay, so f of u is e to the u. And d over dx of f of u would be f prime of u times u prime. Okay? So, here's what we have. We would have the derivative of e to the u as itself, but the derivative, but u prime is 9x to the 8th. Okay? So, in the end, we will have e to the x to the 9th plus 28 power times 9x to the 8th. Writing this in a way it would normally be written would be f prime of x is 9x to the 8th times e to its original power. All right, I'm going to pause. I'm going to put a variation of the chain rule on the board. Okay, now I've left the original chain rule on the board and giving a variation of the chain rule that applies only to an expression to a power. Okay, and that's called the general power rule. I'm going to do this using the chain rule, and then I will do again, because I did do it before. I'm going to do that using the chain rule, and then I'm going to do that. Then I'm going to do it using this rule. Okay, so this will equal 5x to the 9th. Well, I'm just going to write what u is. Okay, this will take the role of u. So u prime would be 5 times 19x to the 18th plus 2x minus 47, which would just be 95x to the 18th plus 2x minus 47. Okay? That's what u prime is. So, f of u would be u to the 25th. d dx of f of u would be f prime of u times u prime. Well, the derivative of this would be 25 u to the 24th times all of this stuff. 95x to the 18th plus 2x minus 47. Okay? And I would simply, what I'm going to do is to save space, I'm going to rewrite it as 25 times all of this times the original u down to the 24th power. Okay, so that's one way to do it. Now I'm going to use the general power rule. Example 1. F of x equals 5x to the 19th plus x squared minus 47x to the 25th power. Okay, now this will take the role of u, and u prime is again 5 times 19x to the 18th plus 2x plus 2x minus 47. Okay. U prime will equal 5 times 19x to the 18th plus 2x minus 47. Okay? So, dx of u to the 25th would become 25 would go to the front, u to the 24th times u prime. Okay? Which would give me 25 u to the 24th times this was equivalent to 95x to the 18th plus 2x minus 47. So 95x to the 18th plus 2x minus 47. Okay? So f prime of x equals 25 times this stuff times, I'm going to replace u with the original expression. That's the 24th power. So either way, you will get the same answer. So I will not be doing the chain rule version anymore. I will be doing the general power rule for the rest of these examples. All right, so here's another example. So this will take the role of u. So u prime is 25x to the 24th. So 25, and then the power of x goes down 1. Okay? So dx of 16 u to the 15th will become, you're going to follow the general power rule. So you will have 16. You're going to go down. The 15 will go to the front. You will go down a power, and then we will also need it times u prime. Okay, which would be 320 u to the 14th power times 25x to the 24th. So 25 times 320 was 6,000. X to the 24th, and I'm going to replace u to the 14th by the original. So 320 times 25 is 6,000. I'm going to keep the x to the 24th, and I'm going to replace u with x to the 25th minus 8 to the 14th power. Oh, and that's f prime of x. All right? As you can see, the general power rule takes less time. Okay? So here's example 3. I have f of x equals the 7th root of 17x cubed minus 29. Well, folks, f of x is equivalent to 17x to the third minus 29 to the 1/7 power. That's what the 7th root would be, the 1/7 power. So this will take the role of u. U prime would be equivalent to 17 times 3x squared minus 0, because the derivative of 29 is 0. So that would simply be u prime equals 51x squared. Okay, so ddx of u to the 1/7 power would equal 1/7 would go to the front, u would go down a power, 1/7 minus 1 times u prime. So that would be 1/7 times u to the negative 6/7 times 51x squared. So I'm going to finish this. F prime of x will be 1/7 times 17x minus the third. Actually, I'm going to go ahead and make this even more concise. 51x squared times 1 is 51x squared. Put over the 7. 51x squared times 1 over 7 is that. I'm going to replace u with 17x cubed minus 29, and it's got to be the negative 6/7 power. Okay. Fourth and final example. F of x equals 14 over f of x equals 14 over 20x minus 19 to the 31st power. Well, first of all, f of x is simply 14 times 20x minus 19 to the negative 31st power. Okay, because that's what a denominator would be, a negative power. So this is u. U prime is simply 20. So dx of u to the of 14 u to the negative 31st would be 14 times negative 31 u to the negative 32nd times u prime. Okay. So that would be 14 times negative 31 u to the negative 32nd times 20. And so f prime of x will equal 14 times minus 31 times 20 is negative 6680. Sorry, 8680. So these three multiplied together is negative 8680. And then we're going to have 20x minus 19 to the negative 32nd power. All right. It fits, and I think I am done.